Alright, so this week we're going to be covering 4.1 and 4.2. And most of this stuff should be a review of what we've covered in SM2, so it shouldn't be too bad. So, first of all, let's start off by defining what the nth root of a actually means, because you're going to hear that. So like in example 1, it's finding the nth root. So an nth root has to deal with radicals. So first of all, a radical, if I draw this is what you should think of whenever you hear the word radical, or even nth root. Okay, so radicals have what we call inside here, there's going to be a number. We call that number n, and this is what we call an index number. Okay, an index number indicates the nth root. Okay, so for example, for a square root, the root is 2. We usually just don't write it. Whenever we use square roots, we don't usually write the index number. It just kind of goes without saying. But then you can also have cube roots. So cube root, the index number would be 3. Then you could have fourth root. And all the way to nth root. And whenever we say of a, we're just basically saying of a number. So you could say what is the second root, or in other words, the square root of a. This would be the square root of a, or the third root of a, or the fourth root of a. So basically, that's what the nth root pretty much means. So in this first example, when it says find the indicated nth root of a, so a here is negative 216. So if you're finding the nth root and n is equal to 3, this means you're finding the cube root. So the index number tells you what number multiplied by itself 3 times is equal to negative 216. What number multiplied by itself 3 times is equal to negative 216. So today we'll cover like how to use a calculator, how to do this, or you could just go through your calculator and try and punch in some numbers that would hopefully get you there. So we could try 8. So we could do 8 times 8 times 8. It's just in a calculator. That's too big. We could try 7. 7 times 7 times 7. That's still too big. 6 times 6 times 6 is 216. So I know 6 multiplied by itself 3 times is equal to 216, but if I need it to be negative 216, then I have to make all these negative. So that's going to equal negative 216. So the nth root of negative 216 is negative 6. That would be the answer. Now for B, again, do the same thing. We have 81, and it's saying that the nth root, that n is equal to 4. So we're trying to find the fourth root of 81. So what multiplied by itself 4 times is equal to 81? So we could try 2, 3, but let's try 3. 3 times 3 times 3 times 3. That's equal to 81. So it's going to be 3. So that's going to be the fourth root of 81. So that's pretty much all it's asking for. Now, here are some core concepts that you guys should remember. Make sure that you guys have access to this and that you refer back to this table right here. So the thing is, if n is an even integer, so basically if you have a square root, or if you have a fourth root, or a sixth root, or eighth root, and so on, so if the root is even, then if a is less than 0, so if you have the square root of a negative number, so negative a, then this means you don't have any real roots. So this basically this just means that you're going to have an imaginary number. If you have a negative square root or a fourth root and so on, you're going to get an imaginary number. You're not going to have any real answers. So there's not going to be any real roots. If a is equal to 0, so basically if you have the fourth root of 0, second root of 0, sixth root of 0, this is just going to be 0. That just goes kind of without saying. And then if you have a regular, like a square root of a, and a is positive, not negative, then you're going to have two answers, which is going to be both a positive and negative. Okay, so this is stuff that you already know. Now, if n is an odd integer, so like up here in example A, n was odd. It was 3. Notice that we can take the odd root of a if a is negative and still get an answer. So unlike an even integer, if a is negative, we won't get an imaginary number. We will get a real number, but you're only going to have one real number. So whenever you have the third root of so if you have like the third root of a or the fifth root, you're only going to have one answer. And that's what we had up here. We only had one answer. It's negative 6. Now, going back to b, like we just said over here, that if a is greater than 0, which it was, a was greater than 0, and n was an even integer, then we should have both the positive and negative. So this should actually be plus or minus 3. Plus or minus 3. Because even if we have negative 3 as this, so we could do negative 3 times negative 3 times negative 3 times negative 3, that's still going to be positive 81. But over here, the only way to get a negative 216 is if you multiply the negative 6 by itself an odd amount of times. So, and then again, if your a is equal to 0, then the third root or the fifth root of 0, seventh root, so on, this is just going to be 0. If a is greater than 0, so like the third root of a positive number, then it's just always just going to be still going to be one real root, so one answer. Okay, so that's the same if it's positive or negative. So if n is odd, you're only going to have one answer. See that? 1, 1, and 1. However, if n is even, if it's less than 0, you have no real solutions. If it's equal to 0, there's only one solution, and that is 0. And if a is greater than 0, then you're going to have 2, which is both positive and negative. Okay, so let's come down here, and this is another review right here of rational exponents. Thing is about rational exponents so rational, which means a number that can be expressed as a ratio or a fraction that you might be more familiar with. So that would be something like a to the 1 over n, or a to the m over n, something like that. Okay, so here are some properties or some rules that you can follow. Thing is that rational exponents are radicals, pretty much. You can convert them into radicals using these formulas. So, for instance, the square root of a is the same thing as a to the 1/2. The third root of a is equal to a to the 1/3. So the nth root of a is equivalent to a to the 1 over n. So yeah, so that's pretty much what a radical and rational, that's the relationship between a radical and rational exponents. Now sometimes this isn't always going to be 1. So sometimes you can have you could say to the 3 over 2. That's a rational exponent. And in this case, we could rewrite this. We could rewrite this to be a to the 1/2 cubed. Because remember that a power of a power, so if you have a squared squared, this is the same thing as a squared times by a squared, which is the same thing as a to the 4th. So basically, you can multiply these exponents to get to simplify it, right? So down here, I can instead of multiplying, I can change this to be 3 as a power of a power. So a to the 1/2 to the 3rd would be equivalent to a to the 3 over 2. Now, what we already discussed before over here is that a to the 1/2 is the square root of a. So that's equal to the square root of a cubed. Okay. So if you just want to use general numbers like m and n, this right here is a formula that helps you convert from a rational exponent to a radical. Okay. And that should be pretty much it. This down here basically just says the same thing, except if you ever have a negative, then that means you flip it to the other. So if you have a negative in the numerator, then you can flip it to the denominator and it then becomes positive. So notice here your exponent is negative, but when you move it to the denominator, it is now positive. So you can do that with any form of exponent, not just rational exponent. But then you see that you follow the same process and you get the same answer, just that this is now on the denominator instead of the numerator. So going through some examples here. So it says to evaluate each expression. So we can evaluate by first simplifying. So 16 to the 3 over 2 is the same thing as 16 to the 1/2 cubed. So we're kind of just separating the fraction out. Now I know 16 to the 1/2 is the square root of 16 cubed, and I know the square root of 16 is 4. And 4 cubed is 4 times 4 times 4, which is equal to 16 times by 4, which is equal to 64. Okay, for B, we have 32 to the negative 3 over 5. So I'm going to split this up. So now I have 32 to the 1/5 to the negative 3rd power. Now 32 to the 1/5 is the same thing as the 5th root of 32 raised to the negative 3. And I believe the 5th root of 32, so again you're trying to find one number multiplied by itself 5 times, that equals 32. And I think that should be 2. Yeah, I think it's 2. So this will be 2 to the negative 3. Now I can reverse this so that so this is over 1. Now I can put this to the denominator, which now becomes 1 over 2 cubed, which makes this positive if I put it in the denominator. And 2 cubed is equal to 8, so I get 1 over 8. Okay. In example 3, it's basically the same thing except asking you to use a calculator. So if you go to a calculator, and I have one here, okay, so in this calculator I'll show you how to input a rational exponent, so 9 to the 1/5. Okay, so first I'm going to start by putting a 9, not pi. Okay, and then you should be able to see like a caret sign, a sign that looks like this in your calculator. So it should be like 9 raised to the, and then in parentheses you want to type in 1 over 5. Depending on your calculator, you can do that. But if you have a more advanced calculator, okay, so if you do that, that's just going to give you squared. So if you use on the left side where you see the squared button there, that's what it will give you. But if you want to use, okay, the caret sign that's on the right side, so I'm holding it down right now. On the right side, you can see it just below the clear button. But that's how you can do that. So 9 caret sign, and then 1 divided by 5. But you want to make sure that you have parentheses around the 1/5. Okay. And then you do enter, and then so that equals 1.5518. So it says round to 2 decimal places, so this is just going to be equal 1.55. Alright, so the next one is 12 raised to the 3 divided by 8. So let's go back to the calculator. So 12 raised to the, and then in parentheses, was it 3 divided by 8? Yeah, 3 divided by 8. 3 divided by 8. Enter. So that is 2.54. Okay, now before we type in this right here, there are a couple ways we can type this into the calculator. But let's convert this to a rational exponent. Okay, so we know that this right here, since it's to the nth root of 4, since the nth root is 4, I can change this to be 7 to the 1 over 4, and that's being cubed. Now I can convert that, since these are being multiplied, I can change it to be 7 to the 3 over 4. And that's what I'll type in here. I'll do 7 raised to the 3 divided by 4. Enter. And that is 4.30. And that's it, using a calculator. Pretty simple. Example 4, so solving equations using nth roots. So it says we want to find the solution. So for A, we have 4x to the 5th is equivalent to 128. So basically we just want to solve for x. So we need to get x all by itself. So if it has a number in front of it, the first thing you want to do is to divide. Get rid of that coefficient next to it. So now this is x to the 5th equal to 128 divided by 4, which is equal to 32. Okay. Now to get x by itself, I can take the 5th root of x, but that means I have to take the 5th root of 32. Now remember that if n is odd, that means we're only going to have one solution. So that means x will only have one solution and not the positive and negative. We're just going to have the positive because a is positive. And the 5th root of 32, I think, is 2. But you could always plug it into your calculator or think of a number multiplied by itself 5 times. That equals 32. For B, we have x minus 3 to the 4th equal to 21. Okay. Now notice here that this is in parentheses right here. X minus 3 is in parentheses, so I cannot add the 3. So my first step would be to take the 4th root of both sides, because that will get rid of this exponent. So when I take the 4th root of both sides, I then get x minus 3 equal to the 4th root of 21. Now also remember that we have the 4th root. So because it is a it's odd, or since because the root is even, when we take the 4th root of something, that means we're going to have both the positive and negative. So that actually means we're going to have plus or minus the 4th root of 21. So we're going to have two answers, plus or minus. Okay? Now here I can add the 3. So I know x is equal to 3 plus or minus the 4th root of 21. If I were to write those answers separately, it'd be x is equal to 3 plus the 4th root of 21, and x is equal to 3 minus the 4th root of 21. So if we want to take the 4th root of 21, we can do 21 raised to the 1 divided by 4, and we get 2.14. So this is equal to 3 plus 2.14 and 3 minus 2.14. And you can plug that into your calculator and get the next one, but I think it should be x is equal to, I think it's 5.14, and this should be something like equal to 0.86. Okay, and that's how you do it, so really not too bad. But that's everything for 4.1. So let me know if you have any questions, email me, or I'll see you in class.